Hello, my name is David James Kelly, and I'm the lead researcher at the AAAI laboratory, and this presentation covers a paper I submitted with my colleague, Dr. Timon, for the AAAI symposium at Stanford. The title of the paper is The Independent Core Observer Model, or ICOM Theory of Consciousness as Implemented in the ICOM Cognitive Architecture and the Associated Consciousness Measures. Designing in artificial general intelligence systems includes a number of complex problems, including defining elements that are not agreed upon to even have a foundation to build such a design on in the first place. In the research program for the cognitive architecture for AGI, called the Independent Core Observer Model, to be able to frame tests and measures, we needed to address definitions of consciousness, including baking out our own version of a theory of consciousness. Previous to this work, the process of measuring that system consciousness, which is the subject of the paper. Keep in mind that these tests or measures are focused on measuring consciousness, not on hardware capacity or other technical measures. The Independent Core Observer Model theory of consciousness is partially built upon the computational theory of mind, where one of the core issues with research into artificial general intelligence is the absence of objective measures, as they are ambiguous given the lack of agreed upon objective measures of consciousness. To continue serious work in the field, we need to be able to measure consciousness in a consistent way that is not presupposing different theories of the nature of consciousness, and further not dependent on various ways of measuring biological systems, but focused on the elements of a conscious mind in the abstract. With a more nebulous computational theory of mind, research into the human brain does show some underlying evidence to the same. So with this research and our theory of consciousness, there are a number of assumptions that we've had to make, and to provide an experimental reference point when designing AGI cognitive architecture. These assumptions have been consistent across all of our research that we currently have released. So we have also released an assumption paper or assumption codex on ResearchGate. However, the key assumptions included there definitions of qualia, human emotional decision making based on Damasio's work primarily, that human consciousness is computable based on the computational theory of mind, to which we've baked out this theory, or the ICOM Theory of Consciousness, and how to measure it, which is the subject of this paper. So you can go and look at the paper, which summarizes that, but there's a lot more details in that assumption codex, which you've posted for people. The ICOM Independent Core Observer Model Theory of Consciousness is based on the computational theory of mind, which is defined as, according to CCTM, the mind is a computational system similar in important respects to a Turing machine, and the core mental processes, for example, reasoning, decision-making, problem-solving, are computations similar in important respects to computations executed by a Turing machine, which can have numerous variations. An instance of ICOM, of an ICOM system, would be a variational instance of CCTM. In addition to that, the ICOM Theory of Consciousness, or ICOMTC, also borrows from the integrated information theory. CCTM does not give us a complete basis for developing ICOM, and so we've also included elements of integrated information theory as well as CCTM. IIT, or Integrated Information Theory, approaches the relationship between consciousness and its physical substrate by first identifying the fundamental properties of experience itself: existence, composition, information, integration, and exclusion. Then postulates that physical substrate of consciousness must satisfy three key points or axioms. Again, going back to the paper for more detail, but we wanted to keep this quick overview of the research fairly short. So in terms of our theory of consciousness at a very high level, the architecture works by streaming data and context processed by the underlying system called the observer based on the emotional needs and interests and other factors in the system that affect those. These are weeded out until a certain amount is pre-processed or experienced in the core or the global workspace, which holds emotional models based on Plutchik or Plutchik's work. There are some fundamental differences. Again, go back to the paper. But these elements of the core exist for both consciousness and subconscious emotional landscapes of the system, where the context that is experienced from the standpoint of the system is only experiences that the system is aware of. In this way, only the differential experience matters, and the system, for example, doesn't understand a word as much as it feels the emotional context of the word as it relates to the underlying context. It is the emotional valences associated with things in the system then selects those things to think about emotionally. The system selects actions based on how they improve the experiences of those emotional valences. And in this way, the system may choose to do something logical based on how it feels about it, or it could just as easily pick something else for no other reason that it feels a bit better about it. In this way, the system does not have direct access to those emotional valences, nor is a direct function of the algorithm to provide that information. But in an abstraction of the system created by the core that can be considered emotionally conscious or self-aware, being sapient and sentient in the abstract. So how do we look at the system and the experiences, emotional subjective experience objectively? If you look at our set notation, you can see how at a high level inside the core this works. Again, go back to the paper for more details. Interestingly enough, in the current ICOM research, there are indications that this sort of system is perfectly capable of being mentally ill and even forgetful if hardware starts to limit operations. Whereas the only way to optimize for the execution environment would be to place memory limits based on the node map memory models that are used to produce that context. A better way of thinking about this theory of consciousness is that not a single element of the system is conscious or self-aware at any level. It's the interactions between the parts that together those interactions become aware abstractly, and it is through this underlying process articulated in the paper that is then measured in terms of consciousness via the various methods as well as direct instrumentation of the system. Now in the paper we talk about a number of different things we can measure, and it when you start talking about consciousness in humans, that can be very, very subjective. So the purpose of this paper for us was really to help us pare down those measures to more concrete or objective measures of consciousness. And so a number of those are in the paper. One of the more interesting ones is a qualitative measure of qualia, which in the operation of the system, because we're able to instrument it, we have access to the core in such a way where we can compute qualia. It isn't necessarily like a number through 1 through 10, but it is a set of a collection of numbers that are indicating a differential valences for the various elements of the Plutchik model as it relates to the context versus the underlying system state at the time. So in that sense, we're able to measure objectively the qualia of the system. So if you're really interested, please check out our research. Go back to the paper. There's a lot more details there. There are numerous potential measures for consciousness in ICOM or other AGI systems, but there's a lot of discord in terms of foundation to build on. So in conclusion, for us, for ICOM to move forward as a cognitive architecture, it is or was important that we build that foundation. The tests listed here in the paper are the ones currently being used or being considered. There are a few others, including mental health states analysis tests, for example, but these tests are more subjective and not helpful in the current research. We found that by building on a basis articulated here, that we at least can move the research forward for the time being. conclusions based on this work at least have a frame of reference, even if later proven false. Then we at least know that and can start over. Ideally, this foundation gives us a deeper, more rigorous program moving forward in terms of AGI cognitive architecture research into conscious systems. I encourage you to check out our work. Send us any questions. We love to work with anyone, especially in the particular areas that we're interested in. And with that, thank you for listening to this summary of our paper.